हाय गाइस, कैसे हैं आप सब। मैं आशा करता हूँ आप सब मजे में होंगे और आप सब की प्रिपरेशन बहुत अच्छे से चल रही होगी। तो मैं आपको यही रेकमेंड करूंगा कि अगर आप पहली बार आए हो इस चैनल पे तो सब्सक्राइब कर लीजिए, क्योंकि 11th और 12th की क्लासेस ऑलरेडी स्टार्ट हो चुकी हैं और मैं हमेशा कुछ ना कुछ वीडियो उन टॉपिक से बना के अपलोड करता रहता हूँ। तो मैंने 11th क्लास के कोनिक सेक्शन का ऑलरेडी पैराबोला और इलिप्स के बारे में वीडियो बना चुका हूं। अगर आप पहली बार आए हैं और आपको जानना है उसके बारे में तो आप प्लेलिस्ट में जाइए और वहां पे उसको देख के और क्लिक करके आप पूरे वीडियो देख सकते हैं। बहुत इजी तरीके से मैंने बताया है। अगर डाउट हो आपको तो आप कमेंट सेक्शन में लिख सकते हैं, मैं आपको सोल्यूशन प्रोवाइड करूंगा। और मैं इस वीडियो में कोनिक सेक्शन का ही हाइपरबोला पार्ट को मैं डिस्कस करने जा रहा हूं। क्या है हाइपरबोला, किस तरह से इक्वेशन को डिराइव करना है, कौन कौन से पैरामीटर्स हैं उसके में, किस तरह से हमें समझना है, मैं सारी चीजें डिस्कस करता हूं। तो बिना टाइम वेस्ट किए
Okay, Vijay. So let's get started with hyperbola now. Yeah?
Okay, sir.
So hyperbola, open the chapter and let's draw the figure 11.29. 11.29.
Okay, sir.
Yeah. So this is the contradictory to the ellipse now. Okay. So let's try to understand. Yeah.
Done, sir.
Done, good. Okay, so here if we just draw the figure 11.29 now, in the as per the ellipse part or the all the whatever the parameters we discussed, everything remains the same. So now let's see here, conjugate axis, the directrix is called the conjugate axis, that's called the center, the y-axis and the x-axis, and you have the two focus now, f1 and f2. Right? First we'll focus on the left hand side part. So wherever the the curve crosses the x-axis, that's called the vertex, and f1 is the focus for you, and you have a center, isn't it? And there are another two focus was there, f2, correct? In ellipse also we had the same thing, f1 was there, f2 was there, vertex was there, and the center was there, isn't it? So everything is same only. And there what was that constant was any point on the ellipse, the distance from the focus and f1 and f2 summation was constant all the time. Instead of summation, now we will change to minus now. In the hyperbola thing, what is constant? The difference is constant. Example, consider the point P1 on the left hand side of the hyperbola. Okay. So when you consider the point P1, so what is the distance from the first focus? P1 F1. P1 F1, correct?
Yes.
Next, what is the P1 F2? P1 F2 is nothing but the distance of second focus from P1. Correct? Now,
yes, sir.
The difference is a constant. Can you see that difference is the constant now?
Yeah.
Now what we are saying, P1 F1 minus P1 F2, absolute value. See, basically P1 F2 is, the distance is more than the P1 F1, or P1 F1 minus P1 F2. You can just have to take the absolute value, correct? So any point we have taken like this, so that should be the constant, isn't it? That should be the constant. Similarly, you take any point on the hyperbola. If you take the P2, then what it will be? If we consider for the P2, then it will be P2F1 minus P2F2, isn't it?
Yeah.
So the difference has to be constant. Clear?
Yes, sir. Clear.
Good. Now, as you already know, all these things are pretty clear to a central hyperbola. Okay. So now, the midpoint of the line segment joining the foci is called the center of the foci. Is called the center of the hyperbola. The line through the foci is called the transverse axis, and the line through the center and perpendicular to the transverse axis is the conjugate axis. So this part is also equally important. The line through the foci is a transverse axis. So basically this line we are talking about F1 to F2. That is called the transverse axis. And the perpendicular to the two foci is called the line joining the two foci is called the conjugate axis. Clear?
Yes, sir. Clear.
Excellent. Now let's draw the figure 11.30 now. Let's try to derive the equation for the hyperbola now. Okay, because we got it, the difference is constant. Isn't it? Difference is constant.
Yeah.
Now in the 11.30 we'll try to understand how the difference is constant and what we are going to equate it. Clear?
Yes, sir. Clear.
Yeah, let's draw the figure 11.30 now. And we'll do the little parameter identification, and then we'll go with the derivation part. Okay,
Okay, sir. Yeah.
so
Yes, sir. Done.
done now. Good. Now,
Yeah.
as you already know the naming convention for the parameter which we have defined in the ellipse, that everything remains the same. Now on the x-axis, from center O to the F2 is the center, right? So that's defined as C.
Yeah.
And from O to F1 is also C. So total distance between the F1, F2 is equal to 2C, correct? Now second part is O to B. Distance O to B is on the x-axis, it's A, and let's label the other part also. Let's say OAB and M. So, and we have the OM is equal to B. Correct, because we don't have anything intersecting on the downward y-axis. Correct. So let's draw this like this. Let's give the parameter conversion like this. Okay, so F1 F2 is equal to 2C, and OB is equal to A, because the distances has to be 2A between the A and B, and OB is the OM is B. Is it okay?
Yes, sir.
Good. Now, in the triangle, you can basically apply the Pythagoras theorem on the, let's say I give this point as N. So you draw the two line which passes through the vertex, and we can apply the Pythagoras theorem in the triangle ONB. O and B.
Oh.
So C square will be equal to B square plus A square, isn't it? OB square plus
Yeah.
AB square will be equal to, ON square. Correct?
Yes, sir.
So you'll get the equation. So once you get this C square is equal to A square plus B square, then B square will be equal to C square minus A square, and B will be equal to square root of C square minus A square, isn't it?
Yeah.
Huh? Now you got
Yes,
the B
sir.
value. Now we know that the equation of, as per the equation hyperbola, P1 F2 minus P1 F1 has to be constant. The difference has to be constant, correct? Okay. Now let's find
Yeah.
P1. So P1 can be at the point A. Huh? If the P1 is at the
Yeah.
point A, so between A to F2 minus A to F1, correct? We'll assume that the point P lies on A, okay? Then AF2 minus AF1 will be equal to AF2 minus AF1. What will be equal now?
It is
See,
will be
AF2 is how
equal
much?
to
C
AB.
plus, no, not C. Basically, this is AF1. AF2 we want. Correct?
Yeah.
So, A minus C or C minus A. C minus A will give you the, the distance between the AF1. AF1 is nothing but C minus A. Correct? And AF2 will be
Yeah.
how much? AF2 is anyway C plus A. Correct? So what will you
Yes,
get
sir.
now? When you substitute the value, let's substitute the value and we'll see. So you have the, let's see, AF2 first we'll find. AF2 is how much? AF2. So AF2 is nothing but A plus C. A plus C minus AF1 is how much? AF1 is nothing but C minus A. C minus A. Correct? So it
Yeah.
becomes A plus C minus C plus A is equal to 2A. So I'll send it to you. Just check this part.
Okay, sir.
Is it clear now?
Okay, sir. Yeah, it's clear now.
Right?
Yeah.
So it's constant, right? The difference, so any point on the hyperbola, the difference from the two focus will be constant. Isn't it? Now,
Yes, sir.
let's go to the eccentricity now. What is eccentricity? Eccentricity, we discussed that it was C by A. Correct? Distance of the center by the distance from the focus, isn't it? C by A. So C is basically the distance from the, distance of the focus by distance of the vertex, correct? C by A. So here, if you just see, C is bigger than A. If you remember the eccentricity formula, eccentricity was E is equal to C by A.
C by A.
C by A. Now here, the distance of C, if you just see if you just see this part, or you can just note it down, this part. Draw the figure 11.31 A part. Let's try to discuss the A part. With that eccentricity we will discuss from here only.
Okay, sir.
Now distance of the focus from the O is, C, correct? C is the distance of the from the center to the F1. O to the F1 is the C distance, correct? Now vertex is distance A from the O. So we have C is greater than A, right?
Yeah.
C is always greater than or equal to A, so always value is more. Now because of that, the eccentricity is always greater than 1. C is greater than A, sorry, so eccentricity is always greater than or equal to 1. So in the hyperbola case, first thing very important is eccentricity is always greater than or equal to 1. Correct?
Yes, sir.
Now, the equation of the hyperbola remains the same because we can actually derive it using the same method. Any point you take it and then the distance between them is constant. Difference of the distance between them is constant. So, x square by a square minus y square by b square is equal to 1. So, in the ellipse case it was plus, but in the hyperbola it becomes a minus. Clear? Now, so it can, hyperbola can form on the x-axis also, it can form on the y-axis also. What's the difference? Let's try to understand now. Because again the same concept, the same major axis and the semi-minor axis. Now, draw the figure 11.31 B part now. In the B part we will discuss about the hyperbola on the y-axis.
Yeah.
Everything remains the same, but here the A value, what we are representing, is on the y-axis.
Okay, sir.
Got it?
Done. Yeah.
So here the equation on the y-axis only it's important because wherever the A is there, A is basically distance from the center O. So if it lies on the y-axis, then the equation of the hyperbola changes. The y square by a square minus x square by b square is equal to 1. So this is point to be noted in this part.
Okay, sir.
Clear?
Yes, sir. Clear.
Excellent. Now let's go to we'll derive the equation of the hyperbola shown in the figure 11.13a with the foci on the x-axis. Now let's go to the deriving the equation of the hyperbola. How did we get the equation x square by a square minus y square by b square is equal to 1 or y square by a square minus x square by b square is equal to 1. So let's draw the figure 11.32 and we'll try to derive the equation now of the hyperbola. Is it fine?
Oh, yeah. Sir?
Yeah.
Done.
Done? Okay. Now, let's consider the point on this part. So this we have the parabola on the x-axis now, right? So we have the f1 is minus c by z minus c comma 0, f2 is c comma 0, and we consider the point, some point on the hyperbola that's called the point pxy, isn't it? And
Yeah.
there's the reference axis that oy. So so we got that. What was that? Yeah, conjugate axis and transverse axis, correct? So that is a terminal name we have to give this part. So we have the conjugate axis. Where is okay. So we have the conjugate axis and the transverse axis. Let's try to write down here. Okay. So in this case, we consider the point P on the hyperbola. Anywhere we can take it. So now from point P, you draw the perpendicular on the, not perpendicular basically, connect the point P to F1 and P to F2 also. Clear? So
Yes, sir. Clear.
any point on the hyperbola, right? So now we know that the difference between the two distances from the PF1 minus PF2 has to be equal to 2a, isn't it?
Yeah.
So that is what the condition for the hyperbola. So this condition, let's satisfy it. So PF1, what is the distance formula for PF1? P is a point whose coordinate is x comma y, any coordinate, huh? And F1 is minus c comma 0 and F2 is c comma 0, correct? Now let's try to find out the distance of PF1 and we'll subtract the distance of PF2 now. We'll substitute in this equation. Is it okay?
Yes, sir.
Now what will be PF1 now? Square root of x plus c whole square plus y square, isn't it? And what is the PF2 now? PF2 will be x minus c whole square plus y square. Should be equal to 2a. Got it? Use the distance formula and try to get the answer. Now when we solve it, let's try solve it. Let's see what we get it now. Okay? And we just... And you remember that b square was equal to c square minus a square. That formula. Let's transpose the... Yeah. Let's transpose the x minus c whole square plus y square to the right hand side. Transpose the square root of x minus c whole square plus y square to the right hand side. And now then square on the both sides. So square root will go off. When the square root goes off, what will remain with? Here you can apply right hand side, you can apply a plus b whole square formula.
Yeah.
So you should get something like this. And cancel the things which you can cancel it out from here.
Okay. Sir.
Yeah. So till where you
So this one level. Yes, sir.
yeah, what did you get the value?
I just expanded all the values inside it, sir.
Yeah, no problem.
Then to
So cancel it out from
quick
the left hand
delete
side,
it.
right hand side. Y square will get cancelled. X
Yeah.
square will get cancelled. C square also will get cancelled. What you will get remained with is 2xc, and here it will be minus 2xc. So you can take it as becomes a 4xc. Right? Something you will get. You will get cx by a minus a is equal to square root of x minus c whole square plus y square.
Okay.
You should get this part. After cancelling everything, you should get this value. If you don't get, let me know, because we should get this value, right?
Yeah.
Now again square
Yeah,
root.
yeah, okay, I get it.
Now again it's square on both the sides, so the square root will go off.
Yeah, so then that will come x square by a square minus y square by c square minus a square equals 1.
Correct. Excellent. What is c square minus a square? It's b square.
Yeah.
Replace that. So your equation of the hyperbola becomes x square minus, no, x square by a square minus y square by b square is equal to 1. Correct?
Yeah.
So this becomes the equation of the hyperbola. Got it?
Yes, sir. Yes, sir, got it.
Excellent. Now, hyperbola, we already found that C is greater than A, and therefore yeah, let's go to the lattice rectum, things like that, and we'll find out now. Yeah, one more thing we will discuss in this part is that, okay, so we can actually get the value of PF1 and the PF2, because once we got the value of equation of parabola, equation of the hyperbola, Px comma y satisfies the above equation then with the 0 less than a less than c. So basically c is greater than a, right? So we can make the y as a subject. When you make the y as a subject, right?
Yeah.
So what will be the value of PF1? PF1 is nothing but PF1 is we have actually calculated PF1 was x plus c whole square plus y square, isn't it?
Yeah.
So y square value, if we substitute it, what you will get? Let's try it out. See, your PF1 distance of point P from the F1 was what? You had then the square root, right? This was the P value, PF1 value. X plus C whole square plus Y square. Okay?
Yeah.
Now Y square you got, and now you have the equation of the hyperbola is x square by a square minus y square by b square is equal to 1. So make the y square as a subject. And substitute the y square value in this PF1 y square. When you make the y square as a subject from the equation of the hyperbola, you will get like this. See, x square by a square
Okay.
minus y square by b square is equal to 1. So transpose y square by b square on the other side will become x square by a square minus 1 is equal to y square by b square. Then y square by y square is equal to b square will get multiplied. Correct? So you got the y square as a subject. This y square you substitute in the PF1. So what you will get when you substitute the y square in the PF1, you will get something like this.
Yeah.
Correct? Now after solving it,
Yes, sir.
you will get a plus, you know, after cancelling the things, what and all get cancelled, so a will come out, and what inside will remain is the a plus c by a x whole square, so that will also come out. So what you will get is a plus c by a x. C square you got c square will make it as c square only, you know, so should be fine. You getting now this part?
Okay.
C x plus c whole square in plus b square x square
Yes,
minus
sir.
c square by a square, isn't it?
Yeah.
Now when you solve this part, when you expand it, what you will get is x square plus c square plus 2xc plus b square, you know, by a square is there, so you can just take the a square, not a square, you can just keep it here on x square, but just multiply b square into x square minus a square b square by a square, isn't it? So when you group the things together, whatever gets cancelled, cancel it out, right? Correct? And then a plus c by a x. You should get this value, a plus c by a x.
Okay.
You try it out. If you are not getting, then let me know. I'll just tell you how to get it.
Okay, sir.
X square plus c square plus 2cx will get it, minus b square x square minus a square b by a square.
Okay, no problem.
You didn't get this part? No problem.
No.
So x plus c whole square plus b square into x square minus a square. So what is the, you got it, a plus c by a into x, right? So you didn't get this part? Okay. So we need to substitute c square is equal to b square plus a square. B square, okay. Yeah. Show me a working, send me a working, let me just check. What,
Yes, sir.
yeah. 0 is less than A less than C. So you have x plus c whole square plus y b square into x square minus a square by a square. Send me a working chart. Let me just check. Okay, so yeah, so you did here is y square is it's b square. Now where is b square? X plus c whole square plus, it should be b square also here. No? B square is missing. X plus c whole square plus b square into x square minus a square by a square, right?
Okay, sir, I see it. Okay.
Here b square also will be there, right? Correct, no? Now I'll just tell you what you need to do in this case. So you have is x square plus c square. So x square plus c square plus 2cx plus b square x square minus b square by a square. So so what did we get here? B square, okay. So x square plus c square is what? B square plus a square, isn't it? So we can just put b square plus a square plus 2cx plus b square x square by a square minus b square. So b square will get cancelled. Now what you will get is x square plus a square plus 2x cx plus b square x square by a square. So b square you can put in terms of the c square, x square plus a square plus 2cx plus x square by a square is equal to b square equal to c square minus a square. I'll just send you, Vijay.
Okay, sir.
So that it becomes easier for you to know that part. X square c square by a square minus x square. X square cancelled. So you get is xc by a. Okay, so now you get is a square plus xc by a whole square plus 2cx. Okay, so I'll just send you this part so that you get the clarity what I'm talking about. Got disconnected. Yeah, can you hear me? Yeah. Can you hear me?
Yes, sir. Can hear you.
Yeah, look, I sent you, Jay. You got it now?
Yes, I'm getting it.
So when you solve it after last step, it will become a plus cx by a whole square. Clear?
Yes, sir. Clear.
Good. So basically PF1 we got it's a plus c by ax. Similarly PF2 you'll get as a minus c by a minus a by c x. Correct?
Yeah.
PF2. Okay. So that's PF1, PF2 when you calculate. So basically total distance is nothing between the 2 points. There's somehow difference between the two points from the two focus will be constant, that is 2a. So that we anyway discussed. So fine. The next part is we proved the equation of the hyperbola with the origin O 0, 0 and transverse axis along the x-axis is x square by a square minus y square by b square is equal to 1. So this becomes the transverse axis here. So you remember that part is whatever we discussed just now is the x square, no, this part, when the origin, when the equation parameter of the origin, so centralized no origin and the transverse axis along the x-axis. Clear? This is the equation of parabola. Fine.
Yeah.
Next, if the if the if the what is called, if your transverse axis lies on the y-axis basically, right, then it will be y square by a square minus x square by b square is equal to 1. So this part only you need to remember that part. Okay.
Okay, sir.
Understood?
Yeah.
Clear?
Yes, sir.
Understood this part, right? Excellent. Now, so Fokai, what you got it now, this part x point. Okay, let's go to the lattice rectum also. No? Lattice rectum will be what? 2b square by a. Oh, that's the standard formula only.
Oh, same as ellipse.
Same, just like the
Okay.
ellipse also is same. Yeah, go to example 14 now. Let's try to do the example 14 so that we can understand. Now, this everything remains the same. Only thing is, c value is changed to a square plus b square, right? Square root of a square plus b square. Rest everything remains the same to you. Everything remains the same to you, just like the ellipse. Clear? Okay,
Yes,
let's
sir,
do
yes.
the example 14 so that we understand better.
Yes, I'll just do that.
Yeah, Danisha, where were we for you? Which one we were doing?
So we finished with estimated useful life.
Yeah, let me just open the book for you. Yeah, till where we finished, Tanisha, for you? We estimate.
So we finished it estimated useful life.
Okay.
So 7.5.4.
Ajay, estimate. Okay. We finished estimated useful life. This part estimation. Okay.
Yes.
So 7.6, right? From 7.6 you need to start, right?
Yes, sir. So I have doubted like 7.5.4.
Your doubt is 7.5.4. Yeah, you can go ahead with the. Yeah, tell me the route.
So it said that the machine, the useful life of the machine is still 5 years. So
Correct.
if the machine still works for there, so it will be counted as a cost of productivity, right?
Machine is still work for the 5 years. Yes, it will be round. It will be counted as productivity. Correct. Yes, you are right.
Okay, sir.
Now, just do one reading of this part, 7.6 part. Just do the reading of it, Tanisha. I'll explain to you these methods, straight line method, other methods. I'll explain to you. Okay. Just finish the reading part of this part, then I'll explain to you. Is it okay?
Okay, sir.
So,
Yeah, Vijay, what's the answer you got?
A is 3, B is 4, C is 5. So the foci are plus minus 5, 0 and vertices are plus minus 3, 0. The eccentricity is 5 by 3 and the lattice rectum is 32 by 3.
Eccentricity is 5 by 3. Correct answer. Excellent. What is the lattice rectum you got?
Lattice rectum is 32 by 3.
Correct answer. A value is 4, B is 1, right?
Yeah.
Oh, excellent. Perfect. So yeah, I think now you got it now, Vijay. Now, yeah, fine.